Okay, in 10.6, we look at solving equations with double angle identities. Make sure that you have watched all the videos for 10.5 because most of the solving techniques are in 10.5, and this one just adds kind of like one more step to it. So we looked at some identities in 10.5, and then in 10.6 specifically double angle, and they do some half angle too. So the basic idea here is that all the things that we learned in 10.5 still work the same, but the solutions when you do the double angle identities, you've got to be a little bit careful with. So let's look at one. Let's say we've got cosine of 2x is equal to 1 over square root of 2. All right, so this one's already solved. We've got cosine is equal to a number. This isn't rationalized, so it doesn't look like what we're used to it looking like. So if we rationalize it like we're supposed to, then we get square root of 2 over 2. So we're looking at cosine 2x equals square root of 2 over 2. So we know where cosine is equal to square root of 2 over 2. Sorry, let's say that we need directions for this because that matters. All right, so let's say that we are solving on, let's say we're solving on 0 to 360 this time. We did radians before. I think it's a little bit easier to see in degrees. Okay, so we find all the places where cosine is positive square root of 2 over 2. So that's at the 45s, right? So now our angle is 2x. So we have 2x equals 45. And then cosine is positive again in the fourth quadrant. So that would be 315. Okay, and normally we would stop here because we're solving on 0 to 360. The problem is we can't stop here. We need all of the solutions on 0 to 360. The next step is going to be to divide by 2, and that's going to cut these in half and make them smaller. So I'm going to go further, and we'll see it happen. So the next solution is going to be 45 plus 360. So you can come over here and do 45 plus 360. That would be 405. And we're going to have another one coterminal to 315. So we could do 360 plus 315 like this. So you get 675. And depending on what your number is here is how far you have to go. So since there's a 2 here, I have to go around the unit circle twice. If there was a 3, then I would have to go around again, 4 would go around again, and so on. Because what happens is when I get my final answer to get x, I need to divide everything by 2. Okay, so technically we should have separate equations here, but you can just do it all in one step. All right, so this gives me 22.5. This gives me 107.5. This gives me 202.5. And this gives me, let's see, 337.5, I think. I probably should have a calculator for these. So hopefully those are right, but that's the basic idea. Now look, when I cut them in half, look at my largest angle. We are just under our cutoff of 360. If I was not just under my cutoff of 360, I would want to come back up here and add another one just to be sure. So how would we add another one? We would take 45 and we would add 360 twice, or we'd add 720. So if you're ever unsure, add another angle, and then I would divide that by 2 as well. So my next one would be 382.5, I think, and that's over 360. So I know that I went too far. I throw those out. Okay, so basically you just keep going until you run out of angles that fit into here. Okay, so that's the main difference. And then you're also just looking for double angle identities in general. So let's try one more. Okay, let's say we have solve on let's do 0 to 2 pi for 2 square root of 3 sine 2x minus 3 equals 0. Okay, so we're going to solve this as an equation, then we're going to solve it as an inequality as well. Same thing, but as an inequality. Okay, so we want to get the sign by itself. The double angle in here doesn't matter. Remember, we're looking for the shape of the equation like we were before. We've got number times function of x, number, 0. So we're trying to get the sign by itself. So it kind of solves like a linear. divide by 2 square root of 3, divide by 2 square root of 3. Okay, so we get that sign by itself. That's our first step. All right, now we have sine equals 3 over 2 square root of 3. This is kind of a mess. So let's rationalize and see what we have. All right, so square root of 3 times square root of 3 would just be whole 3. So these two are going to cancel with this 1 altogether. And we end up with square root of 3 over 2. Okay, so we're looking for all the places where sine is equal to square root of 3 over 2, and our angle is 2x. So sine is equal to square root of 3 over 2 at pi over 3. Sine is positive again in the second quadrant. That's 2 pi over 3. And we need to keep going because we need to at least go around the unit circle 2 times. So I need pi over 3 plus 2 pi, and I need 2 pi over 3 plus 2 pi. Remember this from doing coterminals? So we need a common denominator. So that's going to be pi over 3. So if I multiply this by 3, that's going to be 6 pi over 3. And same thing here. Okay, so this is going to give us 7 pi over 3. And this one is going to give us 8 pi over 3. Okay, so our next ones are 7 pi over 3 and 8 pi over 3. Okay, now when we divide everything by 2, that's the same as multiplying by 1/2. Okay, dividing by 2 is the same as multiplying by 1/2. So I'm going to multiply by 1/2 because that makes our lives easier here than trying to do fraction over, over a number. Okay, so that's going to give us pi over 6. This is going to give us 2 pi over 6, which is pi over 3. This is going to give us 7 pi over 6. And this is going to give us 8 pi over 6, which is 4 pi over 3. Okay, and if you're unsure, you can always go one more angle to make sure that you went too big. 4 pi over 3 is third quadrant, so likely the next one's going to put you over anyway. Okay, so our final answers for this one, let me write them out because they're kind of spread out here, would be pi over 6, pi over 3, 7 pi over 6, and 4 pi over 3. And you should be able to go back to the original equation and test all of these. So you should be able to come back up here into the original equation and plug, like use your calculator to plug all these in. So remember, when you put them in, you're going to put them in as sine of 2 times pi over 6, like that when you put them in your calculator. Okay, so let's keep these solutions because we're going to need them for the next. So now we're going to do the same thing, but we're going to do it as an inequality. Just like we did in 10.5, and you'll see that it's really the same thing. The only difference is in doing this. Okay, so we're going to take this and make it okay, so let's make it less than 0. All right, so if you remember from last section, the first step is to solve f of x equals 0. We already did that. We did that in the last step. So we get pi over 6, pi over 3, 7 pi over 6, 4 pi over 3. Okay, so we got those answers. The second step is to look at the graph, and these are going to be equal to your x-intercepts. Okay, so I put it in my calculator like we did last time, and I'm still in my 0 to 2 pi setting, so this is what I got. And remember that your x-intercept should correspond to your graph if you have them in order, which we do. Yeah. Okay, so we have pi over 6, pi over 3, 7 pi over 6, and 4 pi over 3. Okay, so we want to know where we are strictly less than, so that would be below the x-axis. So we look at the graph to see all the places where we are below the x-axis. So let me put them in a different color here. All right, so here, 0 to pi over 6. And we want to be strictly below. So this gets a little tricky here. We want to be strictly below. So we can't include the x-intercept. But look at 0. At 0, we are below. So that's actually going to be included. Okay, so different things can happen at the two ends. So at 0, we are below, so I do include that one. And then I'm below again from here to here. Okay, so all of this where I'm shading. So that would be pi over 3 to 7 pi over 6, and both of those would be not included. Oops. Okay, and then again here, 4 pi over 3 to 2 pi. So not included at 4 pi over 3. Now 2 pi would be included because we're strictly below, but it's not included here. So if your interval goes to 2 pi, it's never going to be included no matter what your inequality is. So 2 pi is always going to be a round bracket. Okay, so square bracket at 0, round bracket at everything else. All right, so that's the basic idea. So the inequalities don't really change. It's really just the solution part. You've got to make sure that you get all the solutions there so that you have all your x-intercepts. If you go to the graph and you don't have enough x-intercepts, that means you've got to come back to the solution set and get more because your solutions have got to match your x-intercepts.